The InterSystems IRIS 2024.1 data platform introduces vector search, which makes it possible and easy to add semantic search to your applications. Today, I'll be showing you an example of vector search in one of our internal tools and how it can be used to return relevant search results and mitigate data redundancy in the application. So here we have the questions page of the application, and we have a table of question-answer pairings for frequently asked questions, along with additional metadata that I won't get into here. Each row in this table represents a question object, and we see the class definition for that object here. The part that we'll be focusing on specifically is the question and question embedding properties. The question property is a percent text object that represents the question itself, and the question embedding is created when the question is saved. Here, before we save the model, we first check if the question is null, and if it isn't, we create an embedding for that question. An embedding could be thought of as a high-dimensional array that represents the meaning and context of that question text. And this is what drives vector search. Going into it a little further, we see how we generate the embeddings for those questions. This is done using embedded Python and the sentence transformers library. So we generate embeddings for each question in that table. And now I'll show an example of vector search. So we can look up a query like, how does your solution improve quality of care? So with vector search, we found two questions that exist in the database and that are similar to the question we searched for. Rather than relying on keyword matching, we get results that we as humans would consider semantically similar. So I'll copy this question for the next part of the demo. Going back to the questions page, we see that in this table, there are dozens of questions. So a user that is attempting to insert a new question might not have time to read through all of them to determine that the question they're inserting already exists. Or multiple users that are working in the application at the same time might unintentionally insert duplicate questions. With vector search, we can now prevent these potential duplicates. So if I paste in the text that we copied before, we see that we already have form validation that prevents us from adding a question that already has an exact match. However, we know that there are multiple ways that a question can be phrased to essentially ask the same thing. So now with vector search, we can detect that. How does your solution improve quality of care? And I'll leave the answer that's to do for later. So with vector search, we can now identify that there were two potential duplicates for the question we were about to add. So we can either heed that warning and cancel, or we can determine for ourselves that this new question is distinct enough from the existing ones and go ahead with the insertion. So just looking under the hood a little bit, we can see here that the vector search that we use to both return search results and identify potential duplicates does a simple cosine similarity between the question embedding for the question and the embedded version of the query that we entered. And this is the precursor for a whole host of potential features that include Gen AI, like retrieval augmented generation or other things that could further enhance the application. But overall, today, as a recap, we saw how vector search could be used to improve the relevance of search results returned and also mitigate data redundancy in the application. And these are just a couple easy ways that vector search can already add value to your existing applications.